Hi, I'm Tianyi Wang from the University of Hong Kong. Today I'm presenting my extended abstract, Automatic Classification upon CVE Entries and Cybersecurity Articles. Common Vulnerabilities and Exposures, CVE, a famous cybersecurity vulnerability database, is often referenced as a standard in cybersecurity territory for both research and commercial purposes. Common Weakness Enumeration, CWE, has provided useful vulnerability taxonomy on CVE entities, serving as a baseline for identification and classification on cyber weaknesses and vulnerabilities. In order to achieve maximum utilization upon CVE entries and CWE categories, National Vulnerable Database, known as NVD, performs analysis on CVE entries that binds CVEs and CWEs. And here is an example showing that the CVE entry has the corresponding CWE ID 20 in proper input validation. However, the generation process of CWE categories is totally by manual working, and this has made cybersecurity professionals suffer from the unpredictable timing waiting for the up-to-date information to be published. Therefore, we propose automatic classification models that assigns CWE IDs to unlabeled CVE candidates with the adoption of CVE interests that have been labeled with corresponding CWE IDs. Actually, there are a considerable number of researches that have been done upon CVE entries. However, to our knowledge, only one published article was found attempting CVE classification with the help of CVE entries and the corresponding CWE categories. This study proposed naive Bayes on CVEs from 1999 to 2016 and performed vulnerability types classification for the top 10 CWE categories in terms of CWE frequency and acquired a 75.5% accuracy. Due to data unbalancing, we propose an automatic classification model upon CVE entries of the top 10 CWE categories in terms of the CWE frequencies. We propose three different deep neural network models and compared their performances. The first one we propose is the bidirectional LSTM. We applied embedding layers with the LSTM and followed by the dropout layer, fully connected layer, and the softmax. The output has a dimension of 10, which corresponds to the 10 CWE categories. After training with 100 epochs with the learning rate 5 times 10 to the minus 5, we obtained an accuracy of 75.85%, which is slightly higher than the existing work. Here's the loss curve of our model, and we can see that it converges. The next one we propose is CNN. We did the same thing by adding in embedding layer, dropout layer, fully connected layer, and softmax. More specifically, for the CNN part, we used 3 kernel layers, which the kernel sizes are 6 times 6, 5 times 5, 4 times 4, respectively. As a result, after training with the same hyperparameters for the CNN, we got an accuracy of 82.45%, which is much higher. And here's the loss curve, which also converges. The third one is the bidirectional encoder representation from transformers, known as BERT. It is a neural network-based technique for natural language processing pre-training. We used 4 epochs as suggested by the original paper. Then we got the accuracy of 83.73%, which is the highest. And just a reminder, the existing naive Bayes claimed to have 75.5% accuracy. As a result, the novel BERT-based model outperforms LSTM, CNN, and the existing naive Bayes work. Therefore, it shows a potential direction for improvement, that is, improving the fine-tuned BERT. The well-trained classification models can further be improved and adjusted to apply to real-life threat intelligence-related articles and reports for indexing convenience and performance evaluation in the future. That's it. Thank you.
Ladies and gentlemen, my name is Kacper, and I will introduce the notion of the so-called future crimes in relation to the practices of the law enforcement and intelligence services. For the purpose of my work, I call the internet and related modern technologies the new battlefield, where 2 sides of the struggle the criminals on the one side and law enforcement on the other fight and compete for domination. The reason for the use or abuse of technology is quite simple. It's a multi-purpose tool that is easy to use and inexpensive and enables maintaining high degree of anonymity while reaching global goals. Additionally, due to generational changes, the so-called digital natives, new generations of offenders highly skilled with modern technologies will be entering criminal market in the near future. We can see a sudden shift in trends from the traditional notion of cybercrime to abusing technology with the effects in real life circumstances from the preparation stage until the completion of the crime. And the so-called future crimes deal with all aspects of criminal behavior, from regular crime to organized crime, terrorism, violent extremism, up to cyber warfare. One of the things to look at is the open source intelligence-based attacks, where the victim selection and monitoring or target selection is done online using various sources of information. One of the interesting new developments is the abuse of wearable technology to profile victims. One of the interesting cases is the recent Strava data abuse that was used to disclose the location of American military bases abroad. We can see recently that also the so-called pet wearables are used to track the victims or the human victims or their whereabouts. And generally speaking, social media information is most frequently used by the criminals in cases like child grooming, child pornography cases, or human trafficking. Also to groom and profile potential violent extremists. This is a quite well-known problem, but due to the decrease in price of 3D printing technologies, we can expect such crimes to be on the rise in the near future, 3D printing abuse, as well as the attacks on the Internet of Things, either the specific devices owned by specific people or the whole networks of IoT enabled devices, including the medical devices, which pose quite a substantial threat nowadays. In the near future, in our analysis, we also covered the potential abuse of autonomous or semi-autonomous vehicles used as weapons or roadblocks or even kidnapping devices, as well as the use of various types of drones for surveillance as weapons for the delivery of drugs or for the disruption of air traffic control systems. Military robots might seem to be a distant future, but the technology is getting cheaper, so we might brace ourselves for potential abuse of such technology in the future. The next notion is cyber warfare, with a specific stress put on disinformation and misinformation used by rogue governments to attack democracies, as in the cases of US presidential election meddling, the Brexit, or the whole armies of trolls, either humans or bots, that are used to destroy the social fabrics of these societies. The artificial intelligence is a whole new chapter, and the same goes with blockchain or cryptocurrency abuse used by the criminals worldwide for various reasons and objectives. New horizons that we can expect in the criminal market will be the abuse of emerging technologies such as quantum computing and the technologies that are entering the market such as 5G telecom networks that will provide increased capabilities for the criminal offenders or terrorists. So to summarize, those technologies make up the so-called sum of all fears, something that we need to get ready for. If you had any questions, please reach me on email. Thank you very much and goodbye.
Welcome. With my colleagues from the University of Lausanne, we will present some advanced recovery and forensic analysis of MySQL data in deleted states. So databases in general are widely used by organizations to store information that could be very relevant to a wide range of investigations, such as criminal cases, civil disputes, or data breaches. And the idea of this work is to provide some guidance for investigations that involve databases, And we propose a multi-stage approach to the forensic recovery and the forensic analysis of deleted data in databases. And the idea is to have a more comprehensive reconstruction of alteration at the end. So the first stage is to the idea is to have multiple versions of the database of interest, and those versions to have them through time. So we will look at historical databases version. For this, we can use backups of the database, audit logs, but also we can use some carving techniques to find deleted database files. So for instance, for MySQL, it could be FRM files or MYD files. And we could also try to carve some backup files. Once we have those multiple versions of the database, the idea is to compare those different versions to find some records that could have been altered. And so we can find some records that are present in only one version of the database, or we could also find some records that have the same primary key but different values. And so the idea is really to target some records that could be of interest for more in-depth analysis. The in-depth analysis, the idea is now to dive inside the record structure and inside the record data to find exactly what data have been altered. We can also look at deleted records. So database engine usually work in the same way as a file system. So when a record is deleted, the data might still be present inside the file of the database, but it will just be marked as deleted. And so really this third stage, the idea is to really identify what data exactly has been modified, and now the last stage, the idea is to find how. So for this, we will use some contextual analysis of the altered or deleted records. So usually records are added in a sequential manner, and using timestamps of the record and also the position of the records inside the files, we can start to infer some possible alterations. So how the deletion occurred and also when. So to sum up, the idea of this multi-stage approach is first to find some element of comparison using different versions of the database, then using some large screening comparison to try to identify some records of interest, then to look in depth at those records to find what data was modified and or deleted, and then using some contextual analysis, try to understand how the deletion or the alteration occurred. Thank you for your attention, and feel free to contact us if you have interest or any question.